So thanks everyone for great talks. Now, see, my biggest fear is that we might agree too much here.
No, we won't. It is scary.
Good practice. Okay. So I think we probably all agree on the weaknesses of LLMs. So even neural net people now are starting to agree. So I want us to try to self-introspect, and this is still working.
Yeah.
And to try to challenge ourselves as a neurosymbolic emerging community. What do we need to do differently? Because we're clearly not winning yet. So what does it take to win in hard benchmarks and so on to beat LLMs without neurosymbolic? My assumption is maybe it'll be LLMs plus some neurosymbolic ideas. So LLMs will be involved. They can even claim victory with neurosymbolic. But what does it take for us to do that? So in particular, I want to invite hot takes, meaning, crazy, wild, controversial positions that maybe you don't even believe in yourself, but put them out there so that, all right. So Gary is not here. All right, so let me start. So in thinking about, having been thinking about neurosymbolic for the last 6 years, exclusively kind of, I've been noticing there's some fundamental divides, not just at a technical level, but really at a basic intuition level. So one of them is that in ML versus KR, would say there's a sort of a deep belief in an intuition in ML that you should not add knowledge. It's actually very deep and unwritten, I believe. If you add knowledge, it's cheating. So I think there's a deep belief that you must be tabula rasa. You must learn completely from scratch. And I think if you ask KR people, they say, well, not adding knowledge is stupid. That's probably a deep intuitive belief. So I think to bring neurosymbolic together, neuro and symbolic, we can't have both of these things true. Say, so somebody's going to have to, in the end, drop some belief. So I'll give you a few more, and then I'm going to invite you to nominate which of these deep commitments, intuitive commitments, you think we could maybe drop. Say, of course, we would all like the other side to drop their deep intuitive commitments. But which ones are you willing to drop? Yes, coming from, say, a care officer. So you could say there's at least in deep learning, a deep intuition that we should follow neuroscience, guided by how neurons work, even if our current abstractions of neurons are a little shaky as far as mimicking real neurons. You could say maybe in this community, it's more of like a cognitive science intuition. It does accept symbols. The psychological experiments seem to show that we do use symbols. Okay, so these are, I believe, very deep, like almost unshakable type of, axioms for these sides. So, and I give you another one. Well, another kind of divide, at least within ML, you could say there was a certain branches of ML, like support vector machines, that are very principled, believe in certain principles, bounds, learning theoretic bounds, Pixie dimension, whatever, and then probabilistic graphical models, believing axiomatic principles. But then there are the scruffies. The neural net people are scruffies, you could say. So, it works. And here's a toolkit, and with this toolkit, you make things work. And, maybe they would say maybe stuck to your principles. And maybe that's why your stuff doesn't work as well. Okay, so, so let me open it up, and I deliberately wanted to touch a lot of areas of the brain with this. So feel free to comment in other ways as well. But which of the deep beliefs that we sort of have in this room, you might think, maybe we should relax to make the union happen? Anybody?
I could try one then. Let me try to be a bit, maybe this is something I myself don't fully believe, but I'll try. I think one thing that happens today is that it's very important to have metrics. It's very important to have F1 accuracy, everything. It's very important. But I think it should not be too important, right? Because otherwise what happens is I commented this today earlier in my talk. Your poor student has to do all the neuro-symbolic system, but then he has to do all the GPT stuff because he has to compare the accuracies. I think we need better metrics. We've been looking at metrics to evaluate LLMs in my group, and there are like 60 metrics. There's blue, there's, you name it. There are a few metrics for quantifying things that neuro-symbolic systems might add to the picture, like interpretability. For example, I don't know, textuality. I think we should have better metrics, because then you can say, look, my system wins. Your system may be more accurate, but at least in this metric, we're not competing. We're trying to find something better. I don't know if it was clear enough, but I think we need better metrics. Metrics that will quantify whatever neuro-symbolic systems may bring to the picture. Okay. There was wireless.
I think I also agree with the metrics, and benchmarking is also a problem here. We worked actually on creating a benchmark for including constraints in learning, and then we have like 16 tasks, and we realize, okay, the metrics are really not reflective, and the benchmarks are easy. Like when you have low data, then you can improve, but maybe the data is sufficient for what the tasks and benchmarks that you're having. That's why we cannot really show the influence of the external knowledge. The patterns of the knowledge can be extracted from the data. So that is why we cannot see the advantage. But I think as we go and we are dealing with more and more complex problems now, given that the AI becoming more broadly applicable in every area, I think it's becoming very important to really create benchmarks that reflect the actual problems that are important for us to solve in real world. So the gap is there. So we try to do some metrics like, okay, satisfaction of the rules or interpretability or low data. So this is really the type of evaluation that it's not kind of common in the papers that we see. It's just really performance value and task performance that is reported usually. So I think that is one problem that we cannot really promote this kind of techniques. Another is like computational complexity. So we really don't have, there's a bottleneck. Okay, whenever you have GPU computations, you're quick. And when you come to this kind of reasoning, you're slow. So I think if there are like big companies that can invest how we map symbolic processing to some parallel computation and like the sort of computational mean that we have for deep learning, that is, I think, something that probably ambitious direction that we have to follow to really be able to practically apply these techniques in real world setting. I think I had something else, but I forgot, but I can just say that.
Maybe everyone can take a shot at it.
So My view is that you don't necessarily need to give up anything because the whole end-to-end process is so broad. And there are LLMs which are good at certain things and symbolic methods that are good at certain things. And if we can break the problem up and have the LLMs do what they're good at and have the symbolic systems do what they're good at and complement each other, you actually have a big happy family. That's kind of what we're doing at elemental cognition, which I'm gonna talk about tomorrow morning. The second thing that I want to touch on that you mentioned is how do we get attention, I guess, is what you're trying to say. I think that we need to lower the barrier of entry. I think that part of the reason that LLMs got so much attention is you go to a website and you can just start talking to it. Like elementary school kids can do that. Symbolic systems notoriously have a very high bar and it's inaccessible. You need you need to learn a new programming language in order to be good at it and that sort of thing. So I don't know, maybe like leveraging LLMs as a way of making symbolic systems more accessible is a possibility to do.
I think the good things we have, like the properties that matter in certain domains, like safety, validation, verification. This is a way forward. Even though we have all the hype and attention to LLMs, in many domains, you cannot compromise in terms of safety, security, validation, and you cannot have that with LLMs. Even in the talk yesterday, I think Pascal, with all those hallucination problems in many, if not most domains or applications that are not perceived by the general public, we cannot compromise that, and only neuro-symbolic techniques or symbolic techniques can provide you answers to that. Otherwise, we're going to live in an extremely unsafe, unpredictable, and hard world. So I would say that the entry barrier, as Jennifer was saying, is something very important for public perception. But we have to learn how to present the good things that we have. And people actually use these techniques in a large number of applications, as we're talking over coffee break. You know, the hardware industry would not be the hardware industry without validation, verification, and other safety critical domains as well. So we cannot just throw the popular AI techniques and technologies today into certain domains, and the symbolic techniques or the neuro-symbolic techniques, I believe, are one of the way forwards for AI and computer science, but without compromising safety, security, and validation verification.
So I think that we can do, I can imagine that we'll be able to do with less knowledge if we have, you know, multimodal, very high bandwidth systems in the future. But I don't, the other thing that neural net folks push very hard is simplicity in the models and lack of bias. And that I don't think we can get away with. I think that's the wrong direction. We need to move towards more structured models that bake in some of the fundamental some knowledge in terms of how we go about, you know, how it learns, something that encourages compositional learning or abstractions. I don't think that vanilla transformers are going to get you know, leaps better if we don't change the structure. And I also think that I agree with Jennifer and Fabio that Luis, that we can't live inside the LLM. You know, we can't have a training cycle that is completely undebuggable, a huge thing that is, you know, billions of parameters. We have no idea how to train it. It's just unworkable. It's unscalable. We need to have a pipeline in which LLMs are some kind of encoder in the front and decoder or renderer in the back end that makes things look good. And in between, we need something else. We need to have reasoning. We need some more systematic techniques. Just don't think we can scale this as it is now.
So Stuart Russell on that point talks about don't make AI safe, make safe AI. In other words, design it in to be more modularly developable and predictable in its behavior in terms of compositionality. I dream that we could have something more like a programming language with library, extensible libraries for the whole area of neurosymbolic, which has been the direction that neural net stuff has moved. And I don't see why, there's nothing that to me says we couldn't do that in a way that integrates the symbolic and deductive type of reasoning into the guts of learning and reasoning networks. What we call, I think we don't have great vocabulary for this. We should call them something like LR nets as opposed to neural nets. Because it might not just be neural type ML techniques. Historically, there was huge fragmentation in the area of ML and hundreds of different ML approaches and so on. And part of, I think, the advantage of neural nets has been that there is a pretty common approach there. It is one, somewhat sprawling at this point, but one family, really. I don't see why we couldn't come up with maybe not one to start, but a handful of families and get more wood behind fewer arrows as a research, as an R&D community. And in terms of our experience empirically, which would make the case in terms of providing evidence.
So I have a question for Benjamin. So who is going to invest in such a thing? I mean, I have worked on developing programming languages. I mean, this not programming languages, really libraries for deep learning, and I really have the issue with like engineers, right? Engineering part of it, and also like I mean, there are a lot of multidisciplinary in terms of like hardware that you need to really do signal processing quicker. A lot of engineering for representation of the symbolic knowledge and mapping to heterogeneous computations, right? So it is hard. Like DARPA would support such a project. You're not.
I think there's a good chance to get support from DARPA, from NSF also as a fundamental approach. I mean, I think Gary made an interesting point in his talk earlier today. It's like, we're talking so many orders of magnitude more money being put into just burning computational and data wrangling resources. The latter largely, devil may care lessness about the copyright and so on, IP rights to it. But I do think that theory is pretty cheap. The packet learnability, the basics of neural nets, basics of decision trees, decision forests, inductive logic programming. The total research funding to develop those as techniques is a tiny fraction of what just one of the LLMs has been absorbing in terms of yearly budget lately. And so I think that, or let me say, one order of magnitude less, not a tiny fraction. But it's really, theory and algorithms tend to be cheap, but it's hard. It's hard, fundamental work with that guy. So you have to corral the right bunch of researchers to kind of spark off each other to make something like that happen. I think the ML community back in the late 80s and the early 90s was really, that was a pretty special time, ML community, because a lot of these things got invented then. And it wasn't that big a community. It was roughly the size of the current Neuro-Symbolic AI. But I would say it was heavier in people who were theoretically minded. I think we need to attract more people or somehow highlight more the theoretical and conceptual aspects of Neuro-Symbolic. And because right now it's just this kind of messy, like information area where it's not all clear how to kind of compare and contrast different approaches.
All right, so what I learned was Benjamin needs to fund Neuro-Symbolic. and benchmarks. So we come back to benchmarks, but nobody took my bait, by the way, on relaxing any of the principles that we hold. Tim did a little bit. What did you say? That
That we might be able to do with less knowledge, but we can't really do with very generic networks. We need to put more into the structure of the tools that we're using. I was just going to make one comment on the last question though, which is that I think one of the challenges for us is that, if you're just using hardware and blasting through, you get incremental value for incremental effort. It might be a lot of computation, but if you run more GPUs for longer, you tend to get something out of it. In the neurosymbolic world, we kind of have to, it's more sort of periodic or patchy in some way. We have ideas and we try them, and then they work or they don't work, but we don't have a magic bullet to just make things better. And I think that is hard for people who invest in it, because they want to see incremental effort, incremental value for incremental effort. And so it's a sort of economic problem in a way.
I just wanted to comment on the debates that you mentioned. I also think as we have more knowledge, we need less data. But the thing, is that we also translate data to knowledge. So that is also, I think, with human, we have system 1 and system 2, right? As we have a lot of data, then we don't need to use knowledge. We just do pattern matching and we do fast things. But I think we always need these two paradigms, right? So then we need to really see when we need to really give up with the knowledge, because we already have enough experience. But then we need extra knowledge for the new domains that we really don't have data for it. And I think this is like forever going procedure. So there is no place that we can stop. Okay, we have all the data of the world and we don't need knowledge. I don't think that is what's going to happen, because the world is dynamic and we always need to have these two sides. That is my goal.
Yeah.
No, go ahead.
So to continue sort of this line on of inquiry about convincing neuronet people, say, this is borrowing from a conversation with Francesca. So some would say, why do you insist on formal reasoning? Humans don't do formal reasoning. You're asking for something that's actually superhuman. We know from experiments, we don't even do proper probabilistic reasoning. So why be so beholden to these principles? Maybe 80% on these reasoning data sets, even though, of course, a formal reasoner at 100%. Yeah, maybe that's about right, because most people can't get 80% probably. Maybe. So what would you say to that?
I'll say a few words. The same thing was said, ironically, to Jeff Hinton 20 years ago. Why are you doing neural networks? No one is doing neural networks, right? And he said that publicly many times, even at AI conferences. So the fact that some people say that the field has no future is not a best way of deal with science, right? And a lot of money, as was mentioned, Benjamin, is being thrown at LLMs. And I just make an analogy here with CERN. CERN receives huge amounts of money in physics, but not necessarily the best discoveries in physics are done at CERN. So I see the same thing, same parallel happening here. For instance, you mentioned back learning or other concepts in machine learning. They were created before the extraordinary success that we have today of language models. And the good thing about this community is that this community, or the Neuro-Symbolic community, you preserve the principles of computing, the principles of formal methods and theoretical computer science, and the principles of reasoning, because there is not even sometimes an understanding, let's say in the wider LLM arena, of the meaning of reasoning, the meaning of inference, as we're discussing here in other forums. and how important reasoning is to computer science. Let's not forget, computing is reasoning about something. And I believe that the way forward is to keep pushing the barriers and keep working in a rigorous way, using formal methods, using reasoning approaches that are sound, reasoning approaches that have the best properties that we have learned in computing theory.
I think that argumentation is central in pretty large swaths of our society. Finance and many other areas largely revolve around law, which definitely is an argumentation-based approach, and in that sense is formal. Science, technology revolves around science, so does medicine. So the whole kind of aspect of statistical reasoning and what it means to establish a result, formulate a hypothesis, give evidence that it passed, it wasn't rejected, null hypothesis wasn't rejected, and so on. And designing things for controllability with an eye toward causality. Those are essentially pretty formal mechanisms. So I think that the premise that formal reasoning doesn't matter is dead wrong. I think that we'd be, most of us, breaking our backs and dead from doing agriculture of a pretty primitive kind if it weren't for those two areas, specifically law and science. So, so it might not be that in other areas that we're using those patterns of reasoning or intelligence or cognition or whatever you want to call it, in a sort of structured way, to use Tim's term for it. But I think it borrows from that or has aspects of it. So a lot of craft work, I think, is really kind of incremental, scientific, a lot of refinement of business processes, manufacturing processes, and actually of social interactions has that quality as well. We do little experiments and we're applying kind of rational principles to learn in those circumstances, even though we're quite aware of our departures from such rationality or reasoning. We're complicated creatures in the world. It's a complicated place socially. So anyway, so that's my take on the question.
Okay, so I think that the reason that we stick with formal, a big part of it is explainability. Like Benjamin said, right? In law, in finance, whatever, you tell people, oh, you should buy this stuff. Why? Right? So you need to be able to explain how you came to that decision, and the formal reasoning gives you a backbone for doing that. And the other. I don't remember what I was going to say.
Okay. You remember,
I
so
mean,
you remember. So.
Yeah, I will remember.
I mean, like, I see like a lot of studies like try to formalize how human does things, right? So how we think, how we do logic, how we do uncertainty, and we try to formal our understanding of the world as well. So, I mean, now we are going to build a machine. So we start from our formal understanding of how things work, right? So that is a good starting point rather than building something that randomly does things and then try to do the same studies that we do for human now to do a large language model. So that's why I think making things formal is maybe related to what you mentioned. It makes things explainable and we really understand the computations that are going to give us automation.
I don't remember.
No, go ahead.
Or later.
What I said.
Now or later.
No,
No.
later. See, I don't know why this doesn't stick in my head. Does someone want to go?
Don't worry about it. All right. When it comes back, you raise your hand.
Okay.
So benchmarks were mentioned, but ever since ImageNet, I think people realize the importance of benchmarks. I think there's been a profusion of benchmarks actually since then. You could argue we do have a lot of benchmarks. We have benchmarks, and testing neural nets for reasoning and all sorts of things. So what's wrong with our benchmark? Clearly, it does seem to be a common view that, Neuro-Symbolic needs some benchmarks to show itself, but then other people might say there are a lot of benchmarks. So what's your problem? So what do we need exactly that we don't have? Or do we just need to aggregate these benchmarks to show there are also suites of benchmarks?
Well,
Sorry.
I was just gonna say one thing quickly on that, which is that, we can't help it when we create benchmarks, but create benchmarks that serve us a little bit. And I think that happens, people try not to, but I think you see a lot of, for example, in some of the things that I was talking about, you don't see any few shot benchmarks. You don't see, they just don't make benchmarks that have 14 examples in them because no neural net can do it. And so, it's sort of like, well, if we made that benchmark, which is a realistic benchmark for what we want, no one would be able to solve it. So we don't make that benchmark. Another benchmark that we can solve. And so it's a little bit like looking through a keys where the light is with benchmarks also.
Yeah.
So Neuro-Symbolic should have that. So we should make those benchmarks for Neuro-Symbolic.
I don't think people can hear you remote, unless you use a mic.
Make a comment?
I fundamentally believe that we can never win by going to somebody else's sandbox and play. And somebody else has defined a sandbox, you go and try and play, you're not going to win. You have to define your own sandbox. And that applies to a number of things that you guys all talked about. But fundamentally, the way we measure the success, starting with the measure of, our measure really come from information retrieval kind of time of thing, of accuracy and effort measure and such. To what extent is that applicable for the quality of care a doctor provides? To what extent that is accurate with regards to the quality of argument a lawyer makes? It doesn't. So what we have to basically do is that the neuro-symbolic systems are fundamentally fundamentally solving different problems than a search engine solves. Fundamentally different problem than language model and language processing and language generation is about, which language models do well. We have to look for what is language understanding and define the metrics and measurements as well as benchmarks that suit that. So I have to, for example, be willing to look at how the doctors make decisions for diagnosis or treatment following clinical practice guideline. Now think about just this process. This is something that must be done. If the doctor cannot explain that he followed or she followed a clinical process guideline to come to a decision, he is liable, he'll be sued or he'll lose. So he would only or she would only follow, the process of ordering this test, that test, and how they make the decision. We have to be willing to take these kind of decision-making centric applications and both provide the way we measure the success of those as well as the benchmark for those. And then I think we would have our sandbox, let LLMs come and play that. Will make the source of.
Now's as good as time as any. Let me open it up to the whole audience. Any comments on the questions I asked or questions for the audience? Okay.
So sort of reflect on what Amit said. I mean, this whole idea of winning is absurd, right? You don't want to win. What you want to do is establish a set of benchmarks where you show that your techniques perform extremely well and increasingly well, and those benchmarks have to matter to people. So some obvious examples are program verification. right? If you could, over a large corpus, if you could verify the correctness of a program, for large programs efficiently using neuro-symbolic techniques, no one would care whether you were winning or losing against LLMs. I had another example, but that's of a similar ilk, right? So it's not, don't try to claim, don't find splinters in the eyes of language models, right? You know, find a plank that you can actually remove from your eye. So, and for goodness sake, don't use benchmarks like SCAN, right? No one could possibly understand why you should care about your performance on SCAN. I know that's mean, right? But yeah.
But I think also Francesco.
Okay, so.
Fight against me, please.
Yeah.
Like, my view is that I don't necessarily think that like the successful research projects that turned into products win because they won benchmarks first. Like Google became popular because they put it out and then people could find what they want from the web. It's that kind of validation, and the same thing with LLMs. They retroactively went back and say, hey, we passed medical exam or whatever, and say, hey, that's a benchmark. But I don't know that they really had set out with that, with passing the USF.
In point of fact, PageRank did significantly outperform TF-IDF on benchmarks before Google succeeded, right? And
That's
you're
true, but
on
in
that
fact,
too.
if they kept it as a research product, nobody would have known anything. Right, so that's not enough.
So,
I had a comment about, I think if we develop benchmarks where we can systematically trade off knowledge for data, for computation, and also maybe something that elapsed time in terms of dev to validate, or kind of converge to the point where people feel like it's accurate and transparent enough to be willing to trust, then there's a lot of room for benches in, that address various parts of that cross space. But developing benchmarks, I very much agree with Amit's comment that we want to define our own playground, our own sport, as it were, because the most valuable benchmarks are usually when you're at the edge of what you can do, and the benchmark helps attract people to be able to do empirical work with some techniques to try out, sort of one step ahead where things are currently. And if the set of tasks or the setup is not suitable for the sport you're playing, then you're not going to get very far playing in that playground. I really think it's a very important thing to understand about benchmark type work, or the role of benchmarks in R&D.
But it has to be a sport other people are willing to watch.
Sure, everybody wants health, everybody wants manufacturing, everybody wants education.
Everybody would like to be able to file their taxes more simply.
Yeah, so these are good sources of benchmarks. Yeah.
One comment on simple benchmarks is that, can you, just very
Which is that they are simple, but if they differentiate the models that we're currently using, they're still useful. And in fact, if you look at that simple scan benchmark, as dumb as it is, transformers get like 20%. So it said it does say something about those.
Yeah, I agree. It's not useless. It's just not a flagship.
It's nothing that you want to plant your flag on and say, hey, I solved this problem clearly.
It's come and worship.
Right, exactly. It's not your goal.
Where's the mic? Someone else in the
Yeah.
audience? Okay.
Francesco.
Yeah, so first of all, the question that Alex asked, she mentioned me. I told him that it was not a question for me. I completely agree that we need formal methods, we need systematicity and all those things, but I get asked that question very often. And so I wanted to see whether you or anybody that could help in giving a compelling answer, to the people that ask, why do we need, 100% accuracy? Why do we need reasoning? Why do we need, something that is not found in human beings? No? And so I try always to come up with an answer, but I think that I agree with all of you, and some of those answers I think are even more compelling than mine. And then about benchmarks, I think that, yes, we have to come up with our own benchmarks, but I see in putting together benchmarks, I think also yesterday Pascal in her talk gave some results from a paper that he wrote about reasoning benchmarks, large language models measured on reasoning benchmarks. But those benchmarks to me are not really what we need, because those are benchmarks like reasoning problems, like puzzles or whatever, that are measure the human reasoning capabilities that require human reasoning. And then you say, then let's check if what's the accuracy of the large language model on those benchmarks. But that doesn't mean that the large language model can do reasoning, because it doesn't it doesn't check the fundamental characteristics of reasoning, which are like Tim said, systematicity or, consistency over time. So it just says that, for example, you may remember that a few years ago, there was the Vinograd schema challenge. Those questions where there was something missing and they say, oh, if the AI can put that thing that is missing in the sentence, it means that it can do reasoning. Now, Vinograd challenges can easily be done by AI without reasoning, because enough data, enough training close to those sentences. So to me, we have to come up with a different way of measuring what we care about. And then we have to be clear about what we care about. Do we care that the AI is correct in its answer to whatever we want to do? Or do we care that it does reasoning because we want explainability, traceability, and human interaction and all those things? Because I think the kind of benchmarks that we want to design are different depending on what we care about, one of these two things.
So I want to add a little bit to what Francesca just said, and what the key thing to think about to distinguish the class of work that I think we can do well, and that is actually needed by the society. You think about if you think about primarily information-centric activities. The current systems we are going to do very well and can do very well even if they are not doing very well by further data and training. What fundamentally has to come into picture is that we really have to think about activities that humans do, not just information-seeking activity, but decision-making activities that humans do, where knowledge, broadly talked about, in a broad sense, plays a very important role. So again, I come back to this example I was trying to share with you, and this has served me very well. Think about how doctors have to make decisions. There is clinical knowledge that they have to be trained on, for sure. That's fine. And those there is a definition of OCD, obsessive compulsive disorder, has a definition defined in DSM-5, a manual that mental health professional learned from. And that definition has this and not that kind of stuff, right? So it is not simplistic, not totally simple. Furthermore, in a medical decision-making process, they have to use this process guideline, a clinical practice guideline, or we call it process knowledge. These are specific set of things that are not available in a very useful form in what you call data. Yes, you can take the whole DSM-5 and put it in your training thing. Nevertheless, the fact that in all that text, for that particular clinical decision-making process, you got to use that guideline is not going to be something that a neural network, a transform model, a string processing thing is going to discern. Is not going to explicitly understand that in this context, you're going to this set of model, or so this set of knowledge, in this case, guideline. So the point is that looking at these kind of applications, I think these are clearly very practical, important applications. clearly language models and, generative technologies have solved certain problems. There are class of problems that common person care about, and they do. There are class of other applications and problems that they simply have not thought about, that deserve to be thought about, that have a strong role for knowledge, in a broad sense. There is another term that we have easily defined, civilizing AI or value-inspired AI. So human society runs on the value of like laws, regulation, policy, guidelines. These are things that we have, a society, and they inform ethics and morality and other things also. They need to be captured. They can only be captured, but well, in a symbolic sense. You can put them as a text and give it to a language model, but it's not going to again discern and do the work, right? It's not going to explicitly know the context and follow that. So this will be a symbolic form, and that when you build a system to solve these kind of problems, adhere to what the society needs for the value, for the responsibility, you'll have what we need.
So if I may, I have a comment on. I think like if we have the challenge of the benchmark is that if we have really data going to infinity and model size go to infinity, we can solve every problem. That's why I think this, for example, scan, GenScan kind of data, they are interesting because we're trying to characterize the essence of the problem. Let's say, what is compositionality? If I have like 2 levels of nesting, or I have longer lengths. So that is actually interesting. And then you can really characterize the problem and then see if the model can generalize in the novel setting. But the problem is that when you're going to have a larger model that has observed all these data, then your evaluation is not clean, right? So you don't know. That is the problem that we have for benchmarking for language models, because we are advocating for knowledge. And if the knowledge is already in the data, then we cannot see the importance of the knowledge. So that's why we need to really evaluate in the limit, not evaluate going to infinity. So I think that is the problem. And for that, we have to see how we can, if we have benchmarks that are saying, like, if I increment this much, then that will be how it increments the learning. If I increment the knowledge, that is how I can influence. So that is something that is challenging to make, I guess. And the benchmarks need to be dynamic since the models are, we don't see the data.
I think to build off of what Ahmed is saying, there's this suggestion that, in a way, neurosymbolic is hitting the really hard issues that occur in, real tough applications, no-fail applications like medicine. And, the ultimate kind of proof point is in those kinds of applications. I agree with that, but unfortunately, that puts us at, we can't show anything until we build an incredibly important application that has all sorts of buildup needed. So so how can we find something in between?
I suggest that a step towards a process which might lead to something like that is a complete moratorium in this community on proclamations about what neural networks and language models and systems built like that can't do. Right? All of these proclamations are on, they're not just built on sand, they're built on water. Let's just stop it and find some things that we think we can positively do at high effectiveness and with strong civilizational impact.
Just a compliment, Michael, right? So we need to, 15 months ago, we didn't have LLMs, right? Suddenly we got them, right? And got like an operator, right? Which we didn't have before and which solves either hard or problem tasks which were simply not possible before. I mean, we need to admit this, right? So we can only gain out of this. We cannot lose much, right? It's true, yes, now somehow this symbolic AI is trying to find its spot under the sun because it's such a, LLMs are so overhyped. So for this, we need a couple of success stories, right? Obvious success stories, right? I don't know, one possible line of success stories could be, well, LLM supported psych, right? So this is something which I would see as
if that works. Well,
Well,
it does work to some extent, but if it works enough.
enough, good enough, right? But effectively, we have a little bit of a magic in our hands now, which we didn't have before. I mean, you cannot avoid. Plus, right, the youngsters, I mean, here we are mostly over 50, right, or something like this. Which tells the story, right, as well. So youngsters don't care for these techniques.
They don't even see them.
I have all the
What do you mean they don't
students,
care?
I've, very soon working in these things and they get.
Because you instruct them.
No, but
Okay, fine, that is a good story, so my general point is just, I mean, we can only gain, we cannot lose really, right? But success stories have this, right? I mean, some of these papers were towards success stories, but they were not yet success stories. So, and these are benchmarks which are, mentioning in the way.
Well, I want to say something. So first, I totally agree. We should avoid polarization. This is annoying, and people will look at us like, oh, these are the crazy fellows who keep saying, LMs don't do this and that. So I think we can only win. I really think. Now, I agree with everyone. The benchmarks are nice and important. I agree. But in the interest of saying something different, I'll say the benchmarks are really, I don't like them very much. Because, you give a problem, you state a problem. Well, someone will come up with 10,000, 100,000, 1 million instances, and we'll train a network and we win. Okay, fine. So I think benchmarks are important, but I don't think getting better benchmarks is really, get us nowhere. I think we need better metrics. I've said already, so let me say it again. We need better metrics. We need to say, what is it that we want to prove that we do better, okay? And I think there's one thing that is come up with here, which is something like this. In the 90s, okay, I was doing my PhD, and back then, we didn't think that AI, I didn't think, maybe some people, well, many people did think, that AI was out there to imitate people as well as possible, right? I work with Bayesian networks. Bayesian networks do calculations with probabilities that people don't do. And we didn't care. Oh my God, so it's a superhuman because it does Bayes rule. A human can do Bayes rule, but a computer can do it better. So I think we should have neuro-symbolic methods that help this tool that we have now, that we can only win to do things precisely. This thing can answer you and can also solve a problem that is this NP. You can do that? No, nobody can do that. But a computer can do that now. They can help you, can only help you. But it has to answer things, certain things that you want to be answered exactly. It has to answer exactly. You don't want to deal with hallucinations. You ask something, you don't know whether it's right. So this is bizarre. So I'm from the time when AI was built to do a rational thing, not just to imitate what humans do something that will help you. And I think that's what neuro-symbolic systems can do. So I think we should do metrics that reveal that, and then have people build the systems. All right, so that's what I have to say.
I am with Amit here, the kind of using other people's sandbox, you're gonna get dirty and you're gonna lose the game. So, and this community, at least from the beginning, we're never against or, opposing, let's say, the big data community. That was the name in the early 2000s. On the contrary, what we wanna do was to show that machine learning or learning engines could learn to do symbolic processing as well. So at least that's one of the schools that you showed, today in your presentation. So one thing that we can do and we should do is to go back to the principles and show people what we can contribute in a positive sense. I don't see this community as opposing any other community. On the contrary, if you take the history of computer science, what has permeated history is the success of symbolic techniques in computer science. AI has gone through waves, 80s, 90s, 2000s. But in computer science, symbolic techniques have been the greatest success history. So, and I think this community can contribute towards the bigger aim of computer science, that's having richer aims or richer symbolic models, but richer symbolic models that now are combined with richer techniques for machine learning, neuro-symbolic learning.
Okay, we need to close up soon. So we'll just do one more question from the audience. Ideally, someone who hasn't asked a question yet. Anybody, shy people? Okay.
So I think I'm from information retrieval community, so I know the importance of evaluation. And we are already thinking about the user simulation and a more complicated evaluation mechanism that more reflect the real world scenario, precision recall, simplified measures. So I feel that here perhaps we could think about the building simulation agents of users, set up a more realistic, more challenging tasks where safety, all those issues can be measured in a meaningful way. We can simulate the scenarios of patient, technical person, etc. And then we define measures based on interactions and to see if it's safe or it's not. We move to that direction, it seems that we have benchmarks, but those benchmarks are defined there based on the simulation of real scenarios. And then we can see if neuro-symbolic approaches could do better with that to the LAI.
Okay, Francesca, I hope you got an answer to your question.
No, but I have an alternative thing. I mean, maybe one thing is to try to change. Yeah, sorry. So we all been studying and working in trying to embed symbolic reasoning and reliable and trustworthy behavior into LLMs. But maybe at some point or in parallel, we should just say they don't do reasoning. After all, they have not been trained to do reasoning. They've not been trained to do reliable. They've just been trained to solve language, and they did. They did solve human language. We have to be amazed by that. But they did not solve reasoning. They're not closer to human intelligence. They don't do reasoning. This community knows how to do reasoning. So maybe the integration of LLMs that provide things that were not there before and reasoning engines should be done on a less tight integration. Should we say, okay, let's use the LLM for what they're very good at, and let's use the reasoning engine for what they're good, and put them together in some pipeline, like Tim was mentioning, or others as well.
I feel it's important to mention Star Trek computer vision in this context. There's a pretty clear set of front end, which is more or less conversational, and then there's the back end. Awesome amount of human knowledge flowing across the galaxy.
Okay, we're gonna wrap up.
Yep.
But if there's one more burning thing anyone wants to say, really quick.
You can go for 30 seconds.
Okay,
Very quick. High social value applications tend to, much more often than not, mean you want very high accuracy. So you won't get that out of LLM type neural network technology.
You don't want hallucination that cannot be solved without knowledge.
Okay, lots of passion. We'll have to continue this discussion tomorrow. So we'll see you all tomorrow. And also,
Well, I'm sorry, I just wanted to say that there's some history over here. So if you go back to logical philosophy, I mean, philosophy of logic, and sort of philosophy of language, there's something that happens that is similar to what is happening right now. So there was a point in time when Bertrand Russell and others used to hate natural language. They used to say natural language is useless, it's a piece of ambiguous sort of set of things. We should formulate our own language. So we should come up with a different kind of way of representing things. And then Montague and others, Barbara Patti and others, sort of try and, somehow bring these two communities together, natural language community, the people who work on semantics, syntax, etc., and the formal semantics community. And there was this synergy that builds in, and that led to lots of interesting sort of methods, including the sort of resurgence of distributional semantics and others. I think we should probably go back and probably have a look at the history and sort of see what can we learn from history again. repeats.
And claiming that our sort of reasoning is the only thing that counts as reasoning is just the sort of thing that purely symbolic people would do, and it's not true.
Okay, we'll leave that as the last word, and we'll see you all tomorrow. And in general, please sign up to be on the list for future events. This is an ongoing multi-year discussion, multi-decade discussion. So thank you.